So welcome to the course Electrical Engineering, the module number 1. So today we are going to see the lecture number 2. So that is on Ohm's law and Kirchhoff's laws. So first we will see the Ohm's law. So it is one of the most important steps in the analysis of circuits was undertaken by George Ohm. So he's who found the potential difference across the two ends many conductors is proportional to the current flowing between them in 1827. So George Ohm is proposed this law. So that is Ohm's law. So that's why on his name he is proposed, the law is called as Ohm's law. So he proposed the law in 1827. So that is he's by experimentally he's doing one experiment and he's applying the voltage to the conductor. So then current flows into the conductor. Then he found the relationship between the voltage and current. So then that law we can call it as Ohm's law. So what is the statement of Ohm's law? Ohm's law states that here we can define in many ways. So here I am defining that the applied voltage between the conductors, between conductor A and B, is directly proportional to the current, or the current flows to the conductor is directly proportional to the voltage between them. So here another definition is also there. So the ratio of potential difference, that is V between 2 points on a conductor to the current flows between them. So that means here, so let us take here 2 points. Let us take, I am taking that as one resistor and the 2 points are A and B. So let us take this potential difference between the points A and B, I am taken as V, and current flows into this conductor, I am taken as I. So according to Ohm's laws, so current flows into the conductor is directly proportional to the applied voltage, or the current flows into the conductor is directly proportional to the applied voltage. So that is the ratio of potential difference between 2 points. So that is potential difference means we can say V of a two conductors to the current flows into the flowing between them is constant provided the temperature of the conductor do not change. So this is the definition of the Ohm's law. So keeping the temperature is constant, the applied voltage is directly proportional to the current. So this is the statement of Ohm's law. So or if you can remove the proportionality constant, then we will get this R, where R is nothing but resistance of the conductor between the 2 points we have considered now. Okay, so this R is nothing but the conductor, R is nothing but is the resistance. So anyway, we will see the concept of resistance in the different types of elements. There we can study the concept of resistance. Okay, so that is about the definition of Ohm's law. So once again, so in triangle form we can see interchangeably. So the voltage, current and resistances, how it will be changes here. So here the three equations we will see here according to Ohm's law. So they are interchangeably. Okay, the first one is the current I is equals to, if you want to current in the circuit, that is current I is equals to V divided by R, or if you want to measure the voltage across 2 points, V equals to I into R, or if you want to measure the resistance, that R is equals to V by I. So these are all the forms of Ohm's law. Okay, so this can be represented here. These are all interchangeably. So for example, if we can find in the triangle current here, so then current I is equals to V divided by R. Okay, so from this triangle you can see, if you want the current I is equals to V by R, or if you want V is equals to I into R. or if you want R, so the ratio of V by I, voltage to the current. So these are interchangeably, we can see the triangle. Okay, so V is nothing but it is placed on the top section, and I is placed on the left section, and R is placed on the right section of the triangle. So the line divides the left and right side of the indication, so which is multiplied and divided in the top of the section. So this is the interchangeable triangle from Ohm's law. Now, according to the definition of Ohm's law, so that is V is directly proportional to I. So that means there is a linear relationship between the voltage and current. So if you want to draw the characteristics of the voltage and current from the definition of Ohm's law, we will get, if you are varying the voltage here, then current is also varying. That is a linear relationship we are getting here. So that means if you are changing the voltage, then current will be changing in the circuit. So then the curve, the corresponding curve we are getting, the corresponding characteristics we are getting here, linear characteristics we are getting here. So that means here, so V is equals to R into I. So if you remove the proportionality, then we are getting the R. So where R is nothing but the resistance, so that is R is equals to V by I. R is equals to V by I. So this curve will indicate the resistance of the curve. So that is the ratio of V divided by I. So these characteristics we can call it as VI characteristics of resistance. Now let us see what are the limitations of Ohm's law. So there are certain limitations of Ohm's law is there. So this Ohm's law will be applicable for AC as well as DC circuits. So to find the basic circuit problems, to find the current or voltage, we can use this Ohm's law, and we can use this Ohm's law in nodal analysis, mesh analysis. So when we are doing the problems, there we can utilize this Ohm's law. So the Ohm's law has certain limitations also. So what are the limitations that we will see now? So the limitations is it is applicable only to metallic conductors. So it is not applicable for non-metallic conductors, where it is proposed the metallic conductors will propose the property of the linearity property. It is not applicable for non-linear materials. Okay. So next, in practical, when you apply the Ohm's law, the resistance should be constant. The resistance should be constant. So it is not changing with respect to the temperature or other conditions. So Ohm's law calculations becomes difficult in complicated circuits. Ohm's law calculations becomes difficult in complicated circuits. And it does not apply to the nonlinear and unilateral elements. It is not applicable for nonlinear and unilateral elements. So in previous class, we have seen that what are the examples of nonlinear and unilateral elements. So like diodes and transistors, they are unilateral elements. So there we cannot apply the Ohm's law. So this law is used only for linear elements like resistor, inductor, and capacitor, and bilateral elements of the circuit. So these are the limitations of Ohm's law. Next, coming to, we will see what are the applications of Ohm's law, where we can use this Ohm's law. So there are different applications of Ohm's law. So this law is used to determine the different electrical quantities such as current, voltage, resistance, power, conductance, etc. So based on this law, we can use it to find current, voltage, power, resistance, and conductance, etc. There are many electrical appliances like electrical heater, kettle operates based on the principle of Ohm's law only. So whatever we are used in day-to-day life, that is electric heater, kettle, so all these equipments or appliances are operated on the basis of Ohm's law only. and it is also useful for the problem solving related to the equivalent, that is series parallel and series parallel combination of electrical circuits, and nodal analysis, mesh analysis, super node, super mesh analysis. In those concepts also we are going to use the Ohm's law. So this is about the statement, limitations and applications of Ohm's law. Now coming to the next topic, that is Kirchhoff's laws. So here the scientist Kirchhoff has found that two laws. So first law and second law. So the Kirchhoff first law we also called as Kirchhoff current law. So first we will see the statement, then after that I will explain what is the statement. Okay, so statement says that the algebraic sum of the currents meeting at a particular junction is equals to 0. So junction means here you can see on this the junction is nothing but the interconnection of more than two branches or more than two elements, we can say that as the junction. So here, according to the definition of Kirchhoff current law, so the algebraic sum of currents meeting at a particular junction, so let us say the algebraic sum I can indicate that as sigma I at a node, at a particular node or particular junction is equals to 0. That means here we can see the totally 5 currents are represented in the diagram. So here I1, I2, I1, I2, I3, I4 and I5. So from this diagram, I1, I2, I3 are entering into the node, whereas I4 and I5 are leaving out the node. So according to the KCL, so the incoming currents is equals to outgoing current, or we can say the algebraic sum of the currents is equals to 0. That means here I can say that, so here we have to take the incoming current I am taken as positive ones and outgoing currents I am taken as negative ones, or vice versa, you can take any directions. So that is here I am incoming to the node I am taken as a positive current. So therefore I1 plus I2 plus I3, and outgoing current I am taken as minus, so that is I4 minus I5 is equals to 0. So we can say that simply manner the sum of the currents in a particular junction is equals to 0. So if we can separate the negative terms, so then that is we can say that I1 plus I2 plus I3 is equals to I4 plus I5. So that means here the incoming currents is equals to outgoing currents. Incoming currents is equals to outgoing currents or leaving currents. Outgoing currents. So this is the statement of, so this where we can use this Kirchhoff laws means where we can find the parallel circuits in a network. So there we can use the Kirchhoff current law. So in parallel circuits the current will be different, voltage will be same. So that is also we will discuss for the coming classes. So that is how the voltage will be divided in the series circuits and how the current is divided into the parallel circuit, that is voltage division rule and current division rule. That is also we will see coming classes. So this KCL, that is Kirchhoff current law, is used only in parallel circuits. Now let us move on to the next law, that is Kirchhoff voltage law. So Kirchhoff voltage law says that the voltage around a loop, here we can say loop, is equals to the sum of every voltage drop in the same loop for any closed network may equals to 0. So here the voltage around the closed loop. So loop is equals to the sum of every voltage drops in the same loop for any closed network is equals to 0, or simply says that we can say that in simple manner, the algebraic sum of voltages in a closed loop is equals to 0, or we can say that the algebraic sum of voltages and voltage drops in a closed loop is equals to 0. So let us consider here one simple diagram here. So here I am considering one simple network here. So this is a voltage source. Here I am connecting one resistor. So here I am taking the 3 resistors are connected in series. So then we can say that this is the total voltage. This is plus and minus. And this is R1, R2, R3. So let us take this voltage drop across this resistor is I am taken as V1. The voltage drop across resistor I am taken as V2. The voltage drop across the resistor I am taken as V3. So what is saying here is that, so according to the KVL, that is Kirchhoff voltage law, the algebraic sum of currents in a closed loop. Loop means where we have to start here, the loop has to be end at the same point. For example, here you can see A, B, C and D. So here we have started at a point A and the loop is again ends at A only. Then we can call that as closed loop. So the KVL is applicable only in the closed loop only. So according to the statement here of the KVL, so I am writing the equations here. So that is starting from A. So the voltage drop across A to B I am taken as V1, that is plus V1. Here the sign conventions are there here. So either you have to follow potential rise or potential drop here. So 2 cases we have to find here. So here the current is enters from positive to and it is leaves at negative. So I can take that as a potential drop. So potential drop means I can take that as a minus V1. And next one, from the second resistor we can see here the current enters at positive and leaves at negative. So here it is positive to negative means either potential drop will be taken place. So I can take this as minus V2 and from positive to negative here. So again from the resistor 3, so here I am taken as a minus V3. And at the voltage source we have to take in here. So here voltage source, the current here enters at negative terminal and leaves at the positive terminal. So it is potential rise. So that I can take in as it is a positive V is equals to 0. So this is nothing but the algebraic sum of voltages and voltage drops in a closed loop. Is voltage drop I can say means if the here I am taken as a voltages directly. So voltage drop means is nothing but V1 we can take as I into R1. So this is the voltage drop across the resistor. So that we can say that sum of voltages and voltage drops in a closed loop is equals to 0. That is according to the Kirchhoff voltage law. So from this we can say that we can bring it all the negative terminals to the right hand side. Then we can say that V is equals to V1 plus V2 plus V3. V is equals to V1 plus V2 plus V3. So this is the total voltage is equals to the individual voltages across each and every resistor. So this concept is based on the Kirchhoff voltage law and this can be applicable in series circuits and the closed loop circuits. Okay, so this based on this where we can use this KVL means we can use this KVL in the analysis of mesh analysis or loop analysis. So with that loop analysis we can find the voltages at any branch, and current in that any current flows through the any branch we can find very easily. Okay, so that's all for today now. So today I'm closing my session here. So next class we will continue. So thanks for watching. Thank you.